Question 1. Strategic planning requires selecting the most appropriate Oracle Cloud Infrastructure storage solution for a financial services company that needs to store a large volume of historical transaction data. This data is considered highly sensitive, subject to strict regulatory compliance for data privacy and retention, and requires high durability and availability. While the data is accessed infrequently for auditing and reporting, it must be readily retrievable within a reasonable time frame. The company also aims to optimize storage costs over the long term. Which of the following approaches best meets these requirements? Option A. Deploy Oracle Cloud Infrastructure block volume for all historical transaction data, relying on default encryption, and ensure regular backups are performed to a separate region. Option B. Implement Oracle Cloud Infrastructure file storage service for all historical transaction data, configuring it with standard encryption and a robust access control list. Option C. Utilize Oracle Cloud Infrastructure object storage, enabling server-side encryption with customer-managed keys via OCI Vault, and implement lifecycle management policies to transition older data to archive storage. Option D. Store all historical transaction data in Oracle Cloud Infrastructure object storage using default encryption and no specific lifecycle management policies. Correct answer is C. Utilize Oracle Cloud Infrastructure object storage, enabling server-side encryption with customer-managed keys via OCI Vault, and implement lifecycle management policies to transition older data to archive storage. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing performance and cost while adhering to security and compliance requirements. A professional challenge lies in selecting the most appropriate storage solution for sensitive data that requires high availability and durability, without compromising regulatory adherence. The need for a robust, secure, and compliant storage solution for financial data, which is subject to strict regulations, makes careful judgment paramount. Misinterpreting the requirements or choosing an inadequate service could lead to data breaches, compliance violations, and significant financial penalties. Correct approach analysis. The correct approach involves leveraging Oracle Cloud Infrastructure's object storage with appropriate security configurations. Object storage is designed for durability, availability, and scalability, making it suitable for large volumes of unstructured data like financial records. By enabling server-side encryption with customer-managed keys using OCI Vault, the organization ensures that data at rest is protected with a high level of control, meeting stringent compliance mandates for sensitive data. Implementing lifecycle management policies to move older, less frequently accessed data to colder tiers, like archive storage, optimizes costs without sacrificing compliance or long-term accessibility. This approach demonstrates best professional practice by prioritizing data security, compliance, and cost efficiency through a well-architected cloud solution. It aligns with the principle of least privilege and defense in depth for data protection. Incorrect approach is analysis. Choosing block volume without considering the data's unstructured nature and access patterns is an incorrect approach. Block volumes are typically used for boot volumes and databases requiring low latency and high IOPS, which can be significantly more expensive for storing large archives of financial records. Furthermore, relying solely on default encryption without customer-managed keys might not meet specific regulatory requirements for data control and auditing. Opting for file storage service for all financial records without a clear need for POSIX-compliant file system access is also incorrect. File storage can be more complex to manage and potentially more costly than object storage for this use case. While it offers durability, it doesn't inherently provide the same cost optimization benefits through tiered storage as object storage does for archival purposes. Using only standard object storage without implementing encryption or lifecycle policies is a significant regulatory and ethical failure. This approach leaves sensitive financial data vulnerable to unauthorized access and incurs unnecessary costs for data that could be archived. It directly violates the principle of protecting sensitive information and adhering to data retention and security mandates. Professional reasoning. Professionals should approach such scenarios by first thoroughly understanding the data's characteristics, type, access patterns, sensitivity, regulatory requirements e.g. data residency, encryption standards, retention periods, and business objectives, performance, cost, availability. Structured decision-making process involves 1. Requirement gathering, documenting all functional, non-functional, and compliance requirements. 2. Service evaluation, mapping requirements to suitable OCI services, considering their features, cost models, and security capabilities. 3. Security and compliance design, integrating security controls, encryption, access management, and compliance features, auditing, lifecycle management from the outset. 4. Cost optimization, designing for cost efficiency through appropriate service selection and configuration, e.g., storage tiers. 5. Proof of concept/testing, validating the chosen solution against critical requirements. 6. Documentation and review, maintaining clear documentation and seeking peer or expert review. Question 2. Assessment of the most effective strategy for integrating risk management into the design and deployment of a new microservices-based application on Oracle Cloud Infrastructure, considering the need for rapid iteration and evolving threat landscapes. Option A. Conduct a comprehensive, service-specific risk assessment for each OCI service and component before deployment, documenting identified risks, their potential impact, and proposed mitigation strategies, and integrate findings into the architectural design and security controls. Option B. Perform a high-level, generic risk assessment that covers common cloud security concerns, but does not delve into the specifics of the OCI services or the application's unique architecture. Option C. Assume that the inherent security features of Oracle Cloud Infrastructure are sufficient to mitigate all potential risks, eliminating the need for a separate, detailed risk assessment by the architecture team. Option D. Defer the detailed risk assessment until after the application has been deployed to production, focusing solely on initial functionality and performance testing during the development phase. The correct answer is A. Conduct a comprehensive, service-specific risk assessment for each OCI service and component before deployment, documenting identified risks, their potential impact, and proposed mitigation strategies, and integrate findings into the architectural design and security controls. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing the need for rapid deployment and innovation with robust security and compliance requirements. The organization is under pressure to deliver new features quickly, which can lead to shortcuts in the risk assessment process. The challenge lies in ensuring that the risk assessment is not merely a perfunctory step, but a thorough evaluation that informs architectural decisions and mitigates potential threats effectively, especially within the context of Oracle Cloud Infrastructure, OCI services. Correct approach analysis. The correct approach involves a systematic and iterative risk assessment process that is integrated into the development lifecycle. This means identifying potential threats and vulnerabilities specific to the OCI services being used, e.g., OCI Identity and Access Management, OCI Compute, OCI Object Storage, analyzing their potential impact, and defining appropriate mitigation strategies. This approach aligns with best practices for cloud security and compliance, ensuring that risks are understood and managed proactively. In the context of the 1Z0-1072-20 exam, this reflects the architect's responsibility to design secure and resilient solutions by considering potential risks from the outset. This proactive stance is crucial for maintaining the integrity and availability of cloud resources, and is implicitly supported by general IT governance principles that emphasize risk management. Incorrect approach is analysis. One incorrect approach is to defer risk assessment until after the application is deployed. This is a significant regulatory and ethical failure because it means potential risks are not identified or addressed during the design and implementation phases. This can lead to vulnerabilities being exposed in production, potentially resulting in data breaches, service disruptions, or non-compliance with organizational policies or industry standards. It demonstrates a reactive rather than proactive security posture, which is unprofessional and increases the likelihood of costly remediation efforts and reputational damage. Another incorrect approach is to conduct a high-level, generic risk assessment that does not consider the specific OCI services and configurations being implemented. This fails to identify nuanced risks that are unique to the chosen cloud environment and services. For example, a generic assessment might overlook specific misconfigurations in OCI IAM policies or vulnerabilities related to specific OCI network security configurations. This lack of specificity renders the risk assessment ineffective, as it does not provide actionable insights for mitigating actual threats, leading to a false sense of security and potential compliance gaps. A third incorrect approach is to rely solely on the security features provided by OCI without conducting an independent risk assessment. While OCI offers robust security capabilities, it operates on a shared responsibility model. The customer is responsible for configuring and managing security within their cloud environment. Assuming OCI's built-in security is sufficient without a tailored risk assessment for the specific application and data being hosted is a critical oversight. This can lead to misconfigurations or a failure to implement necessary controls, leaving the organization exposed to risks that OCI's default settings do not cover. Professional reasoning. Professionals should adopt a risk-based approach to cloud architecture design. This involves understanding the business objectives, identifying critical assets and data, and then systematically assessing the threats and vulnerabilities associated with the proposed OCI solution. The risk assessment should be an ongoing process, revisited as the architecture evolves or new threats emerge. This iterative process ensures that security and compliance are integral to the cloud strategy, not an afterthought. Decision-making should prioritize the confidentiality, integrity, and availability of data and services, guided by a thorough understanding of potential risks and their impact. Question 3. Consider a scenario where a U.S.-based healthcare provider plans to migrate sensitive patient data to Oracle Cloud Infrastructure, OSI, to leverage its scalability and advanced analytics capabilities. The organization is subject to strict U.S. federal regulations concerning patient data privacy and residency. Which of the following architectural approaches best ensures compliance with these U.S. regulatory mandates? Option A. Utilizing OCI's global network backbone for data transfer and processing, without specific verification of data residency, and relying on the organization's internal security policies to manage compliance. Option B. Migrating the data to OCI services in the nearest available OCI region globally to minimize latency, assuming OCI's general compliance certifications cover all U.S. data privacy requirements. Option C. Selecting OCI services based primarily on their feature set and cost-effectiveness, with a plan to address any specific U.S. regulatory concerns post-migration through manual configuration adjustments. Option D. Deploying the OCI services in OCI regions located within the United States, utilizing OCI's robust security features, and configuring granular access controls and audit logging to meet HIPAA and other relevant U.S. privacy laws. The correct answer is D. Deploying the OCI services in OCI regions located within the United States, utilizing OCI's robust security features, and configuring granular access controls and audit logging to meet HIPAA and other relevant U.S. privacy laws. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture where an organization must balance the benefits of cloud adoption with stringent regulatory compliance requirements. The challenge lies in ensuring that the chosen cloud services and their configurations meet the specific data residency and privacy mandates of the United States, as dictated by relevant U.S. federal and state laws. Architects must not only understand Oracle Cloud Infrastructure, OCI, capabilities, but also how these capabilities map to legal obligations, requiring a deep understanding of both technology and regulatory landscapes. Failure to do so can lead to significant legal penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach involves a thorough assessment of OCI services against U.S. regulatory requirements, specifically focusing on data residency and privacy. This means identifying OCI regions and services that are physically located within the United States and can guarantee that data processed and stored within them remains within U.S. borders. Furthermore, it requires understanding OCI's security controls and compliance certifications, e.g., FedRAMP, HIPAA compliance where applicable, that align with U.S. laws like HIPAA for healthcare data or CCPA for consumer privacy. Leveraging OCI's built-in tools for data classification, access control, and auditing is crucial to demonstrate compliance and maintain an auditable trail. This proactive, compliance-first design ensures that the architecture is not only functional, but also legally sound from inception. Incorrect approaches analysis. Choosing OCI services without verifying their data residency capabilities within the U.S. is a significant regulatory failure. This could involve deploying services in OCI regions outside the U.S., thereby violating data residency laws. Relying solely on general cloud security best practices without specific validation against U.S. mandates, like HIPAA or CCPA, is another failure, as these laws have specific requirements that generic practices may not fully address. Assuming that OCI's global infrastructure automatically complies with all U.S. regulations is a dangerous assumption, as compliance is jurisdiction-specific. Furthermore, neglecting to implement granular access controls and audit logging mechanisms that meet U.S. legal standards for data privacy and accountability can lead to noncompliance and potential data breaches that are not adequately investigated or reported as required by law. Professional reasoning. Professionals must adopt a risk-based approach to cloud architecture design, prioritizing regulatory compliance. This involves 1. Identifying all applicable U.S. federal and state regulations relevant to the data being handled. 2. Mapping these requirements to specific OCI services and their geographical locations. 3. Designing the architecture with compliance controls embedded from the start, rather than as an afterthought. 4. Regularly reviewing and auditing the deployed architecture against evolving regulatory landscapes. This systematic process ensures that technological solutions are aligned with legal obligations, mitigating risks and fostering trust. Question 4. The investigation demonstrates that a financial services company is migrating its customer transaction data to Oracle Cloud infrastructure. The primary concern is ensuring compliance with U.S. financial regulations regarding data privacy and security. Which of the following strategies best ensures adherence to these regulatory requirements? Option A. Implementing OCI's default security configurations and relying on the shared responsibility model for compliance. Option B. Migrating all data without specific encryption, assuming OCI's infrastructure is inherently secure enough for financial data. Option C. Conducting a thorough data classification exercise, implementing granular access controls, encrypting data both at rest and in transit using FIPS 140-2 validated modules, and performing regular compliance audits against relevant U.S. financial regulations like GLBA and state-specific data privacy laws. Option D. Focusing solely on the speed of migration and cost reduction, with compliance checks performed only after the migration is complete. The correct answer is A. Implementing OCI's default security configurations and relying on the shared responsibility model for compliance. Explanation. The investigation demonstrates a scenario where an organization is migrating sensitive customer data to Oracle Cloud infrastructure, OCI. The professional challenge lies in ensuring that this migration adheres to the relevant data protection regulations applicable within the United States, specifically focusing on the principles of data privacy and security as mandated by frameworks like HIPAA for health information or PCI DSS for payment card data, depending on the nature of the sensitive data. The architect must balance the benefits of cloud adoption with the stringent legal and ethical obligations to protect customer information. The correct approach involves a comprehensive data governance strategy that includes data classification, encryption at rest and in transit, robust access controls, and regular security audits, all aligned with U.S. federal and state data privacy laws. This represents best professional practice because it proactively addresses regulatory requirements, minimizes the risk of data breaches, and builds customer trust. It demonstrates a commitment to responsible data stewardship, which is a core ethical and legal imperative in the U.S. An incorrect approach would be to assume that OCI's inherent security features are sufficient without a tailored implementation. This fails to account for the specific data types being migrated and the unique compliance obligations associated with them. For instance, neglecting to implement specific encryption algorithms required by HIPAA for protected health information. 5. Or failing to configure network security controls to meet PCI DSS requirements for cardholder data would constitute a significant regulatory failure. Another incorrect approach is to prioritize cost savings or speed of migration over thorough security and compliance assessments. This can lead to overlooking critical vulnerabilities and noncompliance, potentially resulting in severe penalties, reputational damage, and legal liabilities under U.S. data protection statutes. professionals should employ a risk-based decision-making framework. This involves identifying the types of sensitive data, understanding the applicable U.S. regulations, e.g., HIPAA, CCPA, GLBA, assessing OCI services against these requirements, implementing appropriate security controls, and establishing ongoing monitoring and auditing processes. Collaboration with legal and compliance teams is crucial to ensure all regulatory nuances are addressed. Question 5. Upon reviewing the architecture for a new customer-facing application hosted on Oracle Cloud Infrastructure, OCI, that will process personal data of European Union residents, what is the most critical consideration to ensure compliance with the General Data Protection Regulation, GDPR, regarding data residency and cross-border data transfers? Option A. Assuming that all OCI services deployed within a single OCI region automatically adhere to GDPR data residency requirements, regardless of the service's underlying data processing locations. Option B. Relying on the general security features of OCI to protect personal data, without specifically addressing the GDPR stipulations on data localization and the conditions for international data transfers. Option C. Verifying that the chosen OCI regions for data storage and processing are located within the EU, and if any data must be transferred outside the EU, ensuring that appropriate legal mechanisms like standard contractual clauses are in place. Option D. Prioritizing the use of OCI services that offer the lowest latency and highest performance, even if it means data might be processed or stored in regions outside the EU without explicit consent. The correct answer is C. Verifying that the chosen OCI regions for data storage and processing are located within the EU, and if any data must be transferred outside the EU, ensuring that appropriate legal mechanisms like standard contractual clauses are in place. Explanation. Scenario analysis. This scenario presents a professional challenge related to data residency and compliance within the Oracle Cloud Infrastructure, OCI, environment, specifically concerning the General Data Protection Regulation, GDPR. The core difficulty lies in balancing the technical capabilities of OCI services with the stringent legal requirements of GDPR, which mandates specific controls over the processing and transfer of personal data of EU residents. Architects must ensure that their design choices do not inadvertently lead to non-compliance, which can result in significant financial penalties and reputational damage. The need for a clear understanding of data flow, service capabilities, and regulatory obligations makes careful judgment paramount. Correct approach analysis. The correct approach involves a thorough understanding of OCI's data residency options and the specific requirements of GDPR. This means identifying OCI regions that align with GDPR stipulations for data processing and storage, and ensuring that any data transfers outside of these regions are conducted with appropriate safeguards, such as standard contractual clauses, SCC, or binding corporate rules, BCR, if applicable. Leveraging OCI's built-in compliance features and consulting with legal counsel specializing in data privacy are crucial steps. This approach represents best professional practice because it proactively addresses regulatory requirements, minimizes risk, and demonstrates a commitment to data protection, thereby upholding ethical standards and legal obligations under GDPR. Incorrect approaches analysis. An approach that assumes all OCI services automatically comply with GDPR without explicit verification is a significant regulatory failure. GDPR requires active measures to ensure data protection, not passive assumption. Relying solely on the general availability of OCI services in a specific geographic location, without confirming the data residency of all components and associated data flows, is a common pitfall. This overlooks the fact that some services might process data in different regions or use third-party subprocessors with their own data handling practices. Another incorrect approach is to prioritize cost savings, performance benefits over data residency requirements. GDPR emphasis on protecting personal data means that compliance must take precedence over purely technical or economic considerations. Failure to implement appropriate data transfer mechanisms when data must leave a GDPR-compliant region, such as simply moving data without SCCs or other approved mechanisms, constitutes a direct violation of GDPR cross-border data transfer rules. Professional reasoning. Professionals should adopt a risk-based approach to cloud architecture design, with regulatory compliance as a foundational pillar. This involves 1. Identifying all applicable regulations, e.g., GDPR. 2. Understanding the specific requirements of those regulations concerning data residency, processing, and transfer. 3. Mapping OCI services and their data handling characteristics against these requirements. 4. Designing solutions that explicitly address compliance needs, including selecting appropriate OCI regions and implementing necessary safeguards for data transfers. 5. Engaging legal and compliance experts early and often in the design process. 6. Documenting all compliance-related decisions and justifications. This systematic process ensures that technical solutions are not only functional and performant, but also legally sound and ethically responsible. Question 6. Market research demonstrates a significant demand for a new customer analytics service that leverages Oracle Cloud Infrastructure's object storage and autonomous data warehouse. The project timeline is aggressive, with a target launch date in 3 months. The development team is eager to deploy the core functionality quickly to capture market share. As the OCI architect, what is the most appropriate approach to address the risk assessment requirements for this project? Option A. Perform a high-level, generic risk assessment that covers common cloud security concerns, but does not delve into the specifics of object storage or autonomous data warehouse configurations. Option B. Rely exclusively on the default security configurations provided by Oracle Cloud Infrastructure for object storage and autonomous data warehouse, assuming they are sufficient for all potential risks. Option C. Conduct a comprehensive risk assessment that identifies threats and vulnerabilities specific to object storage and autonomous data warehouse, evaluates their potential impact on customer data, and defines mitigation strategies before the service goes live. Option D. Defer the detailed risk assessment until after the initial deployment and user acceptance testing, focusing solely on functional readiness for the 3-month launch. The correct answer is C. Conduct a comprehensive risk assessment that identifies threats and vulnerabilities specific to object storage and autonomous data warehouse, evaluates their potential impact on customer data, and defines mitigation strategies before the service goes live. Explanation. Scenario analysis. This scenario presents a professional challenge in balancing the need for rapid deployment of a new cloud service with the imperative of conducting a thorough risk assessment. The pressure to meet market demands can lead to shortcuts in security and compliance processes, potentially exposing the organization to significant vulnerabilities and regulatory penalties. The architect must navigate these competing priorities, ensuring that risk mitigation is integrated into the development lifecycle, not treated as an afterthought. Challenge lies in identifying and prioritizing risks that are relevant to the specific Oracle Cloud Infrastructure services being utilized and the data they will process within the context of the exam's specified regulatory framework. Correct approach analysis. The correct approach involves a proactive and integrated risk assessment methodology. This means identifying potential threats and vulnerabilities specific to the OCI services being deployed, e.g., compute, storage, networking, database services, assessing their likelihood and impact, and then defining appropriate controls. This aligns with best practices in cloud security and governance, which emphasize a security by design and risk-informed approach. For the 1Z0-1072-20 exam, this would involve understanding OCI's shared responsibility model and how to implement security controls within the customer's purview. Regulatory compliance is achieved by ensuring that the identified risks and implemented controls address relevant industry standards and legal requirements applicable to the data being handled. This approach ensures that security and compliance are foundational, not add-ons, leading to a more robust and defensible cloud deployment. Incorrect approach is analysis. One incorrect approach is to defer the comprehensive risk assessment until after the service has been deployed and is in production. This is a significant regulatory and ethical failure. It violates the principle of proactive risk management, leaving the organization exposed to known or discoverable vulnerabilities during the critical initial phase of operation. This could lead to data breaches, service disruptions, and non-compliance with data protection regulations, resulting in fines and reputational damage. Another incorrect approach is to conduct a generic risk assessment that does not specifically address the OCI services being used or the nature of the data. This leads to an incomplete understanding of the actual threat landscape and the implementation of irrelevant or insufficient controls, failing to meet regulatory obligations for data protection and security. Finally, relying solely on OCI's built-in security features, without a specific assessment of how they apply to the application's unique requirements and data flows, is also flawed. While OCI provides robust security, the customer is responsible for configuring and utilizing these features appropriately based on their specific risk profile. Professional reasoning. Professionals should adopt a risk-based decision-making framework. This involves 1. Understanding the business objectives and the OCI services required. 2. Identifying all potential threats and vulnerabilities relevant to the chosen OCI services and the data they will process. 3. Assessing the likelihood and impact of these risks. 4. Prioritizing risks based on their potential severity. 5. Designing and implementing appropriate controls, leveraging OCI's security features and best practices. 6. Documenting the entire process and regularly reviewing and updating the risk assessment as the environment evolves. This systematic approach ensures that security and compliance are integral to the cloud architecture from inception, minimizing exposure and meeting regulatory expectations. Question 7. Examination of the data shows that a new microservices-based application is being developed for deployment on Oracle Cloud infrastructure. The development team is under significant pressure to launch the application within the next quarter, and there is a strong emphasis on minimizing initial infrastructure costs. The architect is tasked with ensuring the security and compliance posture of this new deployment. Which of the following approaches best addresses the architect's responsibilities in this scenario? Option A. Defer the formal risk assessment process until after the application has been deployed and is in production, at which point security monitoring logs can be analyzed for potential issues. Option B. Focus solely on meeting the minimum compliance requirements mandated by industry regulations, without performing a detailed risk assessment beyond what is explicitly stated in the compliance checklists. Option C. Prioritize selecting the most cost-effective OCI compute and storage services, assuming that OCI's inherent security features will adequately protect the application and its data. Option D. Conduct a comprehensive risk assessment that identifies potential threats, vulnerabilities, and impacts specific to the microservices architecture and the data being processed, and then design security controls and mitigation strategies accordingly, integrating them into the deployment plan. The correct answer is C. Prioritize selecting the most cost-effective OCI compute and storage services, assuming that OCI's inherent security features will adequately protect the application and its data. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing the need for rapid deployment and innovation with robust security and compliance requirements. The pressure to deliver new features quickly can lead to shortcuts in the risk assessment process, potentially exposing sensitive data or critical systems to undue threats. The architect must navigate competing priorities, ensuring that the risk assessment is thorough and integrated into the development lifecycle, rather than being an afterthought. The challenge lies in making informed decisions about risk mitigation strategies that are both effective and economically viable within the Oracle Cloud infrastructure, OCI, environment. Correct approach analysis. The correct approach involves a systematic and documented risk assessment process that aligns with OCI best practices and relevant regulatory frameworks applicable to the exam's jurisdiction, which is assumed to be US-based for this context, given the exam's origin and typical target audience. This approach prioritizes identifying, analyzing, and evaluating potential risks before and during the deployment of new services. It involves understanding the threat landscape, vulnerabilities within the OCI services being used, and the potential impact of a security incident. Mitigation strategies, such as implementing appropriate OCI security controls, e.g., identity and access management policies, network security groups, encryption, are then selected based on the assessed risk level. This proactive and documented approach ensures compliance, minimizes potential damage, and supports the principle of least privilege, all of which are critical for professional cloud architecture. Incorrect approaches analysis, an approach that focuses solely on the cost-effectiveness of OCI services without a commensurate evaluation of security risks is professionally unacceptable. This failure stems from a disregard for the potential financial and reputational damage that can result from a security breach, which often far outweighs initial cost savings. It also violates ethical obligations to protect client or organizational data. Another incorrect approach is to assume that OCI's built-in security features are sufficient without performing a specific risk assessment for the intended workload. While OCI offers robust security, the shared responsibility model means the customer is responsible for configuring and managing security within their tenancy. Relying solely on default configurations without understanding specific threats and vulnerabilities for the deployed application or data is a significant regulatory and ethical failure, potentially leading to non-compliance with data protection laws and a breach of trust. Finally, deferring the risk assessment until after a security incident has occurred is a reactive and highly unprofessional approach. This demonstrates a lack of foresight and a failure to adhere to fundamental risk management principles. It exposes the organization to maximum potential harm and can lead to severe legal and financial repercussions, as well as a breakdown in professional responsibility. Professional reasoning. Professionals should adopt a risk-based approach to cloud architecture. This involves establishing a clear framework for identifying, assessing, and treating risks throughout the project lifecycle. Key steps include understanding the business context and data sensitivity, identifying potential threats and vulnerabilities specific to the OCI services and the application, analyzing the likelihood and impact of identified risks, and prioritizing mitigation efforts based on risk appetite and regulatory requirements. Regular review and updates to the risk assessment are also crucial as the cloud environment and threat landscape evolve. This systematic process ensures that security and compliance are integral to the design and operation of OCI solutions, fostering trust and resilience. Question 8. The performance metrics show a consistent increase in latency for critical user-facing applications over the past quarter, coinciding with a steady rise in cloud infrastructure costs. As the cloud architect, you need to address both issues. Which of the following approaches best balances performance, cost, and operational integrity? Option A. Focus on identifying and scaling down the most expensive services within the cloud environment, assuming they are the primary drivers of both cost and potential performance issues. Option B. Immediately implement a broad cost-saving strategy by reducing the compute instance sizes across all non-production environments to free up budget for performance-critical resources. Option C. Propose an immediate, significant reduction in the allocated memory and CPU for all application tiers to curb escalating infrastructure expenses. Option D. Conduct a detailed performance analysis of the affected applications and underlying infrastructure to identify specific bottlenecks and resource utilization patterns before proposing any changes. Correct answer is D. Conduct a detailed performance analysis of the affected applications and underlying infrastructure to identify specific bottlenecks and resource utilization patterns before proposing any changes. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing cost optimization with performance and availability requirements. The architect must interpret performance metrics, understand the implications of different service configurations, and make a decision that aligns with business objectives and potential regulatory considerations, even if not explicitly stated in the prompt. The challenge lies in the potential for a seemingly cost-saving measure to negatively impact critical business functions or introduce unforeseen risks. The architect needs to move beyond a superficial understanding of metrics and consider the broader impact of their decision. Correct approach analysis. The correct approach involves a thorough investigation of the root cause of the performance degradation before implementing any changes. This aligns with best professional practice by prioritizing a data-driven, analytical methodology. It demonstrates due diligence, ensuring that any proposed solution directly addresses the identified problem rather than treating symptoms. This approach minimizes the risk of introducing new issues or exacerbating existing ones, which is crucial for maintaining service integrity and customer trust. From a regulatory perspective, while no specific regulations are mentioned for this exam jurisdiction, a proactive and investigative approach to performance issues is implicitly aligned with principles of operational resilience and risk management, which are foundational to many compliance frameworks. It ensures that the cloud environment is managed responsibly and reliably. Incorrect approach is analysis. Implementing a broad-stroke cost-saving measure without understanding the performance impact is a significant professional failure. It prioritizes financial considerations over service quality and user experience, which can lead to reputational damage and loss of business. This approach is reactive and potentially harmful, as it could degrade performance for critical workloads. Ethically, it demonstrates a lack of commitment to delivering a reliable service. Suggesting an immediate, drastic scaling down of resources based solely on cost without a performance analysis is equally problematic. This demonstrates a superficial understanding of the relationship between resource allocation and performance. It risks under-provisioning, leading to system instability, data loss, or service outages. Such an action could have severe business consequences and, in certain regulated industries, could even lead to non-compliance with service-level agreements or operational standards. Focusing solely on the most expensive components for potential reduction without a comprehensive performance analysis is also a flawed approach. It assumes that cost is directly proportional to performance impact, which is not always true. Some expensive components might be critical for specific functionalities or security, and their reduction could have disproportionate negative effects. This approach lacks the necessary analytical depth and could lead to unintended consequences. Professional reasoning. Professionals should employ a structured decision-making framework when faced with performance and cost challenges. This framework typically involves 1. Problem identification. Clearly define the observed issue, e.g., performance degradation. 2. Data gathering and analysis. Collect relevant metrics and logs to understand the scope and root cause of the problem. 3. Hypothesis generation. Formulate potential explanations for the observed issues. 4. Solution exploration. Brainstorm and evaluate various solutions, considering their impact on performance, cost, security, and availability. 5. Risk assessment. Analyze the potential risks associated with each proposed solution. 6. Decision-making. Select the solution that best balances objectives and mitigates risks. 7. Implementation and monitoring. Deploy the chosen solution and continuously monitor its effectiveness. This systematic approach ensures that decisions are informed, justifiable, and aligned with overall business and technical goals. Question 9. The control framework reveals that a new application processing sensitive customer data is being deployed to Oracle Cloud Infrastructure. Which approach to risk assessment best aligns with the principles of secure and compliant cloud architecture? Option A. Prioritize rapid application deployment and defer any formal risk assessment activities until after the application has been live for a significant period. Option B. Conduct a comprehensive risk assessment during the initial design phase, document all identified risks and mitigation strategies, and establish a schedule for periodic reassessment and ongoing monitoring of the deployed application's risk posture. Option C. Delegate the entire risk assessment process to a separate security operations team, with minimal involvement from the cloud architect during the design and deployment phases. Option D. Perform a high-level risk assessment only during the initial deployment to ensure basic security controls are in place, with no formal plan for ongoing review. The correct answer is B. Conduct a comprehensive risk assessment during the initial design phase, document all identified risks and mitigation strategies, and establish a schedule for periodic reassessment and ongoing monitoring of the deployed application's risk posture. Explanation. This scenario presents a common challenge in cloud architecture, balancing the need for rapid deployment and innovation with robust security and compliance requirements. The professional challenge lies in ensuring that the risk assessment process is not merely a perfunctory step, but an integral part of the design and operational lifecycle, especially when dealing with sensitive data or regulated workloads. The Oracle Cloud Infrastructure, OSI 2020 Architect Associate exam emphasizes understanding how to build secure and resilient cloud solutions, which inherently requires a thorough understanding of risk management principles within the OCI context. The correct approach represents best professional practice because it integrates risk assessment directly into the architectural design and ongoing operational phases. This proactive stance allows for the identification and mitigation of risks before they can impact the business or violate compliance mandates. By continuously monitoring and reassessing risks, architects can adapt to evolving threats and changes in the OCI environment or regulatory landscape. This aligns with the principle of security by design and demonstrates a commitment to responsible cloud adoption, which is a cornerstone of professional ethical conduct in IT. An incorrect approach that focuses solely on initial deployment without ongoing review fails to address the dynamic nature of cloud environments and the evolving threat landscape. This can lead to compliance gaps and security vulnerabilities that may not be detected until an incident occurs, resulting in significant financial and reputational damage. Ethically, this demonstrates a lack of due diligence and a failure to uphold professional responsibilities to protect organizational assets and data. Another incorrect approach that prioritizes speed over a documented risk assessment process is fundamentally flawed. While agility is a benefit of cloud computing, it should not come at the expense of security and compliance. This approach risks introducing unmitigated vulnerabilities and noncompliance, which can have severe legal and financial repercussions. Professionally, this is unacceptable as it disregards established best practices for risk management and security. A third incorrect approach that delegates risk assessment entirely to a separate team without architectural input creates a disconnect between design and security. While specialized teams are valuable, the architect is ultimately responsible for the security posture of the solution. Without the architect's direct involvement and understanding of the risks identified, mitigation strategies may not be effectively integrated into the design, leading to a less secure and compliant architecture. This can also lead to misinterpretations of risk and ineffective controls. The professional decision-making process for similar situations should involve a structured approach to risk management. This includes 1. Identifying assets and their criticality, 2. Identifying potential threats and vulnerabilities, 3. Analyzing the likelihood and impact of these threats, 4. Evaluating existing controls and determining residual risk. 5. Developing and implementing mitigation strategies. 6. Continuously monitoring and reviewing risks and controls. This iterative process ensures that risk management is an ongoing activity, not a one-time event, and that it is deeply embedded within the cloud architecture lifecycle. Question 10. Analysis of the organization's rapid migration of critical business applications to Oracle Cloud Infrastructure, OSI, reveals a pressing need to establish a systematic approach to identifying and mitigating potential threats and vulnerabilities. The IT leadership is eager to realize the benefits of cloud scalability and agility, but has not yet formalized a process for evaluating the inherent risks associated with this transition. Which of the following represents the most appropriate initial step in addressing this risk management imperative within the OCI environment? Option A. Focus on optimizing cloud spending by selecting the most cost-effective OCI service tiers and configurations, assuming security is a secondary concern addressed later. Option B. Immediately implement advanced security monitoring tools across all migrated OCI resources to detect and respond to any ongoing security incidents. Option C. Rely solely on post-migration penetration testing and vulnerability scanning to uncover security weaknesses after the applications are live in OCI. Option D. Conduct a comprehensive risk assessment to identify, analyze, and prioritize potential threats and vulnerabilities specific to the OCI services being utilized and the data being migrated. The correct answer is D. Conduct a comprehensive risk assessment to identify, analyze, and prioritize potential threats and vulnerabilities specific to the OCI services being utilized and the data being migrated. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid cloud adoption and the need for robust risk management. The organization's desire to leverage OCI services quickly for competitive advantage must be balanced against potential security vulnerabilities, compliance obligations, and operational disruptions. Careful judgment is required to ensure that the speed of deployment does not compromise the integrity or security of sensitive data and critical business processes. The correct approach represents best professional practice because it integrates risk assessment as a foundational element of the cloud adoption strategy. By proactively identifying, analyzing, and prioritizing potential risks before and during migration, the organization can implement appropriate controls and mitigation strategies. This aligns with general principles of IT governance and security best practices, which emphasize a risk-based approach to technology implementation. Specifically, within the context of OCI, This approach supports adherence to Oracle's shared responsibility model, where understanding and managing risks associated with customer-managed components is paramount. It also implicitly supports compliance with various data protection regulations by ensuring that risks to data confidentiality, integrity, and availability are addressed from the outset. An incorrect approach that focuses solely on technical migration without a preceding risk assessment fails to address potential security gaps. This could lead to the deployment of services in configurations that are vulnerable to unauthorized access or data breaches, representing a significant ethical and regulatory failure. Such a failure could violate data privacy laws, e.g., if personal data is mishandled, and lead to reputational damage and financial penalties. Another incorrect approach that prioritizes cost savings over comprehensive risk evaluation is also professionally unacceptable. While cost optimization is important, it should not come at the expense of security or compliance. Neglecting critical security risks to achieve short-term cost benefits can result in much larger expenditures later due to incident response, recovery, and regulatory fines. This demonstrates a failure in professional duty to protect the organization's assets and stakeholders. A third incorrect approach that relies on post-migration security audits as the primary risk management mechanism is flawed. While audits are valuable, they are reactive. Waiting until after deployment to identify risks means that vulnerabilities may have already been exploited, or that the cost of remediation is significantly higher. This approach lacks foresight and proactive risk mitigation, which are hallmarks of professional IT architecture and security practices. The professional decision-making process for similar situations should involve a structured risk management framework. This framework should include phases for risk identification, e.g., through threat modeling, vulnerability scanning, and business impact analysis, risk analysis, evaluating likelihood and impact, risk evaluation, prioritizing risks based on severity, risk treatment, developing and implementing mitigation strategies, and ongoing risk monitoring and review. For OCI deployments, this process should be tailored to the specific services being used and the data being handled, ensuring alignment with Oracle's security, best practices, and relevant compliance requirements. Question 11. Process analysis reveals that a financial services firm is migrating sensitive customer financial data to Oracle Cloud infrastructure. The firm operates under strict U.S. federal regulations, including those from the SEC and FINRA, which mandate robust data security, privacy, and auditability. Which of the following approaches best ensures that the OCI architecture meets these regulatory obligations while also delivering on functional and performance requirements? Option A. Focus the architectural design on meeting business functionality and performance goals, with the understanding that a separate compliance team will review and address any regulatory gaps post-deployment. Option B. Conduct a comprehensive risk assessment that explicitly maps SEC and FINRA regulatory requirements to specific security controls, data handling policies, and audit mechanisms within the proposed OCI architecture, integrating these findings into the design from inception. Option C. Delegate the responsibility for regulatory compliance entirely to the OCI managed services provider, without direct involvement from the cloud architect in the design and validation of compliance controls. Option D. Prioritize the implementation of OCI services that offer the highest performance and scalability, assuming that Oracle's inherent security features will satisfy regulatory compliance. The correct answer is D. Prioritize the implementation of OCI services that offer the highest performance and scalability, assuming that Oracle's inherent security features will satisfy regulatory compliance. Explanation. Scenario analysis. A cloud architect is tasked with designing a new Oracle Cloud infrastructure, OCI, solution for a financial services company. The company handles sensitive customer financial data and is subject to stringent U.S. federal regulations, including those governed by the Securities and Exchange Commission, SEC, and the Financial Industry Regulatory Authority, FINRA. The challenge lies in ensuring that the OCI architecture not only meets functional and performance requirements, but also demonstrably adheres to these complex and evolving regulatory mandates regarding data security, privacy, and auditability. Failure to do so could result in significant financial penalties, reputational damage, and loss of customer trust. Correct approach analysis. The correct approach involves proactively integrating regulatory compliance requirements into the risk assessment and architectural design phases. This means identifying all applicable U.S. federal regulations, SEC, FINRA, etc., and translating their mandates into specific security controls, data handling policies, and monitoring mechanisms within the OCI environment. This includes leveraging OCI's built-in security features, implementing robust access controls, data encryption, logging, and auditing capabilities, and ensuring that the chosen OCI services and configurations are compliant. This proactive, compliance-by-design methodology is best professional practice because it minimizes the risk of noncompliance, reduces the cost of remediation, and builds a foundation of trust with regulators and customers. It aligns with the principle of security by design and privacy by design, which are implicitly expected under U.S. financial regulations. Incorrect approaches analysis, an approach that focuses solely on technical performance and scalability without explicitly mapping these to regulatory requirements, is professionally unacceptable. This fails to address the core mandate of U.S. financial regulations, which prioritize data protection and integrity. It represents an ethical failure by neglecting the fiduciary responsibility to protect customer data as mandated by law. An approach that relies on a hope for the best mentality, assuming OCI's general security features are sufficient without specific validation against SEC and FINRA requirements, is also professionally unsound. This demonstrates a lack of due diligence and a failure to understand the specific obligations imposed by U.S. financial regulators. It is an ethical lapse as it exposes the company to undue risk. An approach that delegates all compliance responsibility to a separate team without involving the cloud architect in the design process is flawed. While specialized teams are important, the architect is crucial in translating compliance needs into technical implementations. This siloed approach can lead to misinterpretations and gaps in the architecture, creating regulatory vulnerabilities. It is a failure of professional collaboration and accountability. Professional reasoning. Professionals should adopt a risk-based approach that prioritizes understanding and mitigating regulatory risks. This involves 1. Identifying all relevant U.S. federal regulations applicable to the industry and data being handled. 2. Conducting a thorough risk assessment that maps regulatory requirements to potential threats and vulnerabilities within the OCI environment. 3. Designing the OCI architecture with compliance as a primary objective, integrating security and data governance controls from the outset. 4. Documenting all design decisions and compliance justifications. 5. Establishing continuous monitoring and auditing processes to ensure ongoing adherence to regulations. Question 12. Operational review demonstrates that a new microservices-based application is being developed for deployment on Oracle Cloud infrastructure, with a tight deadline for market entry. The development team is eager to leverage OCI's managed services to accelerate deployment. Which approach to risk assessment is most appropriate to ensure both rapid delivery and robust security posture? Option A. Form a detailed risk assessment only after the application has been fully developed and deployed to the production environment on OCI. Option B. Assign the entire responsibility for the risk assessment to a dedicated security operations team, with minimal involvement from the cloud architect. Option C. Rely exclusively on automated security scanning tools to identify and report vulnerabilities, assuming these tools will cover all potential risks. Option D. Conduct a comprehensive risk assessment during the initial design and planning phases, integrating identified risks and mitigation strategies directly into the architecture and deployment plans. The correct answer is D. Conduct a comprehensive risk assessment during the initial design and planning phases, integrating identified risks and mitigation strategies directly into the architecture and deployment plans. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing the need for rapid deployment and innovation with robust security and compliance requirements. Challenge lies in ensuring that the risk assessment process is not merely a procedural checkbox, but an integral part of the design and operational lifecycle. The pressure to deliver features quickly can lead to shortcuts in risk identification and mitigation, potentially exposing the organization to significant threats. The architect must navigate these competing demands, ensuring that security and compliance are embedded from the outset, rather than being an afterthought. Correct approach analysis. The correct approach involves integrating a comprehensive risk assessment into the cloud adoption framework, specifically during the design and planning phases. This aligns with best practices for cloud security and governance, which emphasize a proactive, risk-based approach. By identifying potential threats, vulnerabilities, and their impact early on, the architect can design controls and implement security measures that are proportionate to the identified risks. This proactive stance is crucial for meeting regulatory obligations, e.g., data protection, industry-specific compliance, and maintaining the confidentiality, integrity, and availability of data and services hosted on Oracle Cloud infrastructure. It ensures that security is a foundational element of the architecture, not an add-on. Incorrect approach is analysis. One incorrect approach is to conduct a risk assessment only after the application has been deployed and is in production. This is a reactive and fundamentally flawed strategy. It fails to address risks inherent in the design and configuration, potentially leading to immediate exposure. From a regulatory perspective, this approach can result in non-compliance with data protection laws that mandate security by design and by default, as well as industry-specific regulations that require risk assessments to inform system development. It also increases the cost and complexity of remediation, as vulnerabilities discovered post-deployment are often more difficult and expensive to fix. Another incorrect approach is to rely solely on automated security scanning tools without a human-driven, context-aware risk assessment. While automated tools are valuable for identifying known vulnerabilities, they often lack the ability to understand the business context, the criticality of the data being processed, or the specific threat landscape relevant to the organization. This can lead to either overlooking significant risks that are not easily detectable by signatures or focusing on low-impact issues while ignoring more critical ones. This approach can also lead to a false sense of security, as it may not adequately address risks related to misconfigurations, insider threats, or complex attack vectors. Regulatory frameworks often require a more nuanced understanding of risk that goes beyond simple vulnerability scanning. A third incorrect approach is to delegate the entire risk assessment process to a separate security team without active involvement from the cloud architect. While collaboration is essential, the architect is best positioned to understand the technical intricacies of the OCI environment and the application's architecture. Without the architect's input, the risk assessment may be incomplete, inaccurate, or fail to consider the practical implications of proposed mitigation strategies within the cloud context. This can lead to unrealistic security recommendations or a failure to identify risks that are specific to the chosen OCI services and their configurations. This siloed approach undermines the principle of shared responsibility in cloud security and can lead to gaps in oversight and control. Professional reasoning. Professionals should adopt a risk-based approach that is iterative and integrated throughout the cloud architecture lifecycle. This involves 1. Understanding the business context and data sensitivity. 2. Identifying potential threats and vulnerabilities relevant to the OCI services being used. 3. Assessing the likelihood and impact of identified risks. 4. Prioritizing risks based on their potential impact. 5. Designing and implementing appropriate controls and mitigation strategies. 6. Regularly reviewing and updating the risk assessment as the environment and threat landscape evolve. This systematic process ensures that security and compliance are not afterthoughts but are woven into the fabric of the cloud architecture, leading to more resilient and secure solutions. Question 13. Consider a scenario where a financial services company is migrating a critical customer-facing application to Oracle Cloud Infrastructure, OCI. The application requires low-latency access to large volumes of customer data, and the company operates under strict data residency regulations that mandate all customer data must reside within the European Union. Architect has identified OCI Object Storage as a suitable service for storing this data due to its scalability and durability. However, the architect needs to select the most appropriate region for deploying this object storage to meet both performance and regulatory requirements. Which of the following approaches best addresses the architect's responsibilities in this scenario? Option A. Deploy OCI Object Storage in the Frankfurt region, as it is geographically closest to the majority of the company's European customer base, ensuring optimal performance. Option B. Deploy OCI Object Storage in the London region, as it offers the lowest latency for the application's data access patterns, and the company has a significant presence there. Option C. Deploy OCI object storage in the U.S. East Ashburn region, as it has the highest availability and performance metrics across all OCI regions globally. Option D. Deploy OCI object storage in a region within the European Union, such as Frankfurt or Amsterdam, after verifying that the chosen region complies with the company's data residency regulations and offers acceptable performance characteristics for the application. The correct answer is A. Deploy OCI object storage in the Frankfurt region, as it is geographically closest to the majority of the company's European customer base, ensuring optimal performance. Explanation: this scenario presents a professional challenge due to the critical need to balance performance optimization with data residency and compliance requirements, particularly within the context of Oracle Cloud Infrastructure (OCI) services. The architect must ensure that the chosen storage solution not only meets the performance demands of the application, but also adheres to the strict data sovereignty regulations applicable to the client's industry and geographic location. Failure to do so could result in significant legal penalties, reputational damage, and loss of customer trust. The correct approach involves a thorough understanding of OCI's storage services and their regional availability, coupled with a deep dive into the client's specific regulatory obligations. Selecting OCI object storage in a region that aligns with the client's data residency requirements, while also considering performance characteristics like latency and throughput for the specific application workload, represents best professional practice. This demonstrates due diligence in understanding both technical requirements and regulatory mandates, ensuring a compliant and performant solution. An incorrect approach would be to prioritize performance solely based on proximity to the end users, without verifying data residency compliance. This could lead to storing sensitive data in a jurisdiction that is not permitted by the client's regulations, resulting in a direct violation of data sovereignty laws. Another incorrect approach would be to select a storage service that is not available in the required region, even if it offers superior performance, as this would render the solution non-compliant from the outset. A third incorrect approach would be to assume that all OCI services inherently meet all regulatory requirements without explicit verification, which is a failure of due diligence and can lead to unforeseen compliance breaches. Professionals should approach such situations by first identifying all applicable regulatory frameworks and data residency mandates. This should be followed by a detailed assessment of the application's technical requirements, including performance, availability, and scalability. Next, they must map these requirements against the capabilities and regional availability of OCI services, paying close attention to compliance certifications and data handling policies for each service and region. Finally, a risk assessment should be conducted to evaluate potential compliance gaps and performance trade-offs before making a final architectural decision. Question 14. Stakeholder feedback indicates a growing concern regarding unauthorized access to sensitive data stored within OCI object storage buckets. They are requesting a robust solution that ensures only authorized personnel can view, modify, or delete specific data sets, while also maintaining auditability of all access attempts. The current architecture relies on basic network security controls, which approach best addresses these concerns while adhering to OCI best practices for identity and access management. Option A. Enhance Virtual Cloud Network, VCN security lists and network security groups, NSG, to further restrict inbound and outbound traffic to the object storage endpoints. Option B. Develop and implement a custom authentication and authorization service external to OCI, integrating it with object storage to manage all access requests. Option C. Rely on the default IAM policies provided by OCI, assuming they offer sufficient protection for sensitive data without further configuration. Option D. Thoroughly configure OCI identity and access management (IAM) policies, leveraging features like dynamic groups, conditional access, and fine-grained permissions to restrict access to object storage resources based on user roles and actions. Correct answer is D. Thoroughly configure OCI identity and access management (IAM) policies, leveraging features like dynamic groups, conditional access, and fine-grained permissions to restrict access to object storage resources based on user roles and actions. Explanation: scenario analysis. This scenario presents a common challenge in cloud architecture where security requirements, driven by stakeholder feedback, clash with the perceived operational simplicity of a chosen service. The core difficulty lies in balancing robust security posture with the practicalities of implementation and ongoing management. Architects must navigate the tension between compliance mandates and the desire for efficient, user-friendly solutions. The need to protect sensitive data while ensuring accessibility for authorized users requires careful consideration of various security controls and their implications. Correct approach analysis. The correct approach involves a thorough evaluation of the Oracle Cloud Infrastructure, OSI, Identity and Access Management, IAM, services capabilities to meet the specific security requirements. This includes understanding how IAM policies can be granularly defined to restrict access to sensitive data based on user roles, resource types, and even specific actions. Leveraging IAM's features like dynamic groups, conditional policies, and multi-factor authentication, MFA, directly addresses the stakeholders' concerns about unauthorized access and data exposure. This approach aligns with best practices for cloud security, emphasizing the principle of least privilege and robust access control mechanisms, which are fundamental to maintaining a secure cloud environment as per OCI's recommended security guidelines. Incorrect approach is analysis. Implementing a custom, external authentication solution without fully exploring OCI's native IAM capabilities represents a significant regulatory and ethical failure. This approach bypasses OCI's built-in security controls and compliance certifications, potentially introducing vulnerabilities and making it harder to audit access. It also increases operational overhead and complexity, deviating from best practices that advocate for leveraging managed services where appropriate. Relying solely on network-level security, e.g., VCN security lists, without addressing identity-based access control is another failure. Network security is a crucial layer, but it does not inherently prevent unauthorized access by authenticated but improperly authorized users. This neglects the principle of defense in depth, where multiple security layers, including strong identity management, are essential. Finally, assuming that the default IAM configurations are sufficient without a specific review against stakeholder requirements is a critical oversight. Default settings are often designed for broad usability and may not meet stringent security mandates, leading to potential compliance gaps and security risks. Professional reasoning. Professionals should approach such situations by first thoroughly understanding the specific security requirements and the underlying regulatory or compliance drivers. This involves engaging with stakeholders to clarify their concerns and expectations. The next step is to conduct a comprehensive assessment of the cloud provider's native services, such as OCI IAM, to determine if they can adequately address these requirements. This evaluation should consider features, limitations, and integration capabilities. If native services are insufficient, then and only then should the architect explore custom solutions, carefully weighing the added complexity, security risks, and maintenance burden against the benefits. A structured decision-making process involves documenting the requirements, evaluating potential solutions against these requirements and best practices, and clearly articulating the rationale for the chosen approach, especially when deviating from native services. Question 15. Market research demonstrates that organizations are increasingly adopting Oracle Cloud Infrastructure, OSI, for sensitive workloads. As an OCI Architect Associate, you are tasked with designing a secure and compliant solution for a new application that will process customer financial data. Considering the OCI shared responsibility model and common regulatory expectations for data protection, which of the following architectural approaches best aligns with best practices for security and compliance? Option A. Implement granular identity and access management (IAM) policies to enforce the principle of least privilege for all users and services, and configure network security controls such as security lists and network security groups (NSG) to restrict traffic flow based on the application's specific needs. Option B. Grant broad administrative privileges to all users involved in the application's development and maintenance to streamline access and reduce management overhead. Option C. Deploy security controls without a detailed understanding of the specific data being processed or the applicable regulatory frameworks, opting for a generic security posture. Option D. Rely exclusively on Oracle's default security configurations for OCI services, assuming that Oracle's baseline security is sufficient for all customer workloads. Correct answer is A. Implement granular identity and access management, EAM, policies to enforce the principle of least privilege for all users and services, and configure network security controls such as security lists and network security groups, NSG, to restrict traffic flow based on the application's specific needs. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing the need for robust security and compliance with the operational efficiency and cost-effectiveness of cloud services. The challenge lies in interpreting and applying the Oracle Cloud Infrastructure, OSI, shared responsibility model, which dictates responsibilities between Oracle and the customer, within the context of specific regulatory requirements. Architects must ensure that their design choices not only meet functional requirements, but also adhere to the principle of least privilege and data protection mandates, which are critical for maintaining trust and avoiding breaches. The complexity arises from the shared nature of cloud security and the need to accurately delineate where customer responsibility begins and ends. Correct approach analysis. The correct approach involves a thorough understanding of OCI's security services and how they map to the shared responsibility model. Specifically, leveraging OCI identity and access management (EAM) policies to enforce the principle of least privilege is paramount. This means granting users and services only the permissions necessary to perform their intended functions, thereby minimizing the attack surface. Furthermore, implementing network security controls like security lists and network security groups, NSG, to restrict traffic flow to and from resources is essential. This aligns with best practices for defense in depth and regulatory compliance, as it demonstrates a proactive stance on data protection and access control. The regulatory framework for cloud services, particularly concerning data privacy and security, mandates such granular control. Incorrect approach is analysis. Granting broad administrative privileges to all users, even with the intention of simplifying management, represents a significant regulatory and ethical failure. This violates the principle of least privilege, a cornerstone of secure cloud architecture and a common requirement in data protection regulations. Such an approach dramatically increases the risk of unauthorized access, data leakage, and accidental misconfigurations, leading to potential compliance violations and reputational damage. Relying solely on Oracle's default security configurations without customization is also problematic. While Oracle provides a secure baseline, the shared responsibility model clearly places the onus on the customer to configure and manage security controls appropriate for their specific workloads and data sensitivity. Ignoring this responsibility can lead to security gaps that regulatory bodies would deem unacceptable, as it signifies a failure to implement due diligence in protecting sensitive information. Implementing security controls without a clear understanding of the data being protected or the specific regulatory requirements applicable to that data is another failure. Security measures must be tailored to the risk profile of the data. A one-size-fits-all approach, without considering data classification and relevant compliance mandates, e.g., GDPR, HIPAA if applicable to the data, can result in either over-provisioning security, leading to unnecessary costs and complexity, or under-provisioning, leaving data vulnerable and non-compliant. Professional reasoning. Professionals should approach cloud security design by first identifying all applicable regulatory and compliance requirements. This forms the foundation for all subsequent architectural decisions. Next, a deep dive into the OCI shared responsibility model is necessary to clearly define the boundaries of Oracle's and the customer's security obligations. The principle of least privilege should be applied rigorously when designing IAM policies. Network security should be implemented using a defense-in-depth strategy, with granular controls at multiple layers. Finally, continuous monitoring and auditing of security configurations and access logs are crucial to ensure ongoing compliance and to detect and respond to potential threats. This systematic approach ensures that security and compliance are integral to the design, not an afterthought. Question 16. Which approach would be most effective for deploying a new customer-facing application on Oracle Cloud Infrastructure, ensuring both rapid availability and adherence to foundational security best practices as outlined by OCI architectural principles? Option A. Utilize a single, large virtual cloud network, VCN, with minimal segmentation and assign read-only access to all cloud resources for all users to simplify management. Option B. Deploy all application components to public subnets for maximum accessibility and grant broad administrative privileges to the deployment team to expedite the setup process. Option C. Prioritize immediate deployment by skipping detailed IAM policy configuration and relying solely on default network security settings, with plans to address security later. Option D. Implement robust network security groups, NSG, to control traffic, configure granular identity and access management, EAM, policies based on the principle of least privilege, and enable comprehensive logging and monitoring services from the outset. The correct answer is D. Implement robust network security groups, NSG, to control traffic, configure granular identity and access management, EAM, policies based on the principle of least privilege, and enable comprehensive logging and monitoring services from the outset. Explanation. This scenario presents a professional challenge in balancing the need for rapid deployment of critical infrastructure with the imperative to adhere to robust security and compliance standards. The pressure to launch services quickly can lead to shortcuts that compromise long-term security posture and potentially violate regulatory requirements, even within a cloud environment. Careful judgment is required to ensure that speed does not come at the expense of fundamental security principles and adherence to Oracle Cloud infrastructure. Best practices as defined by the 1Z0-1072-20 exam syllabus. The correct approach represents best professional practice because it prioritizes a layered security strategy and leverages OCI's native security services. Implementing network security groups, NSG, for granular ingress/egress control, utilizing identity and access management, EAM, policies for least privilege access, and enabling logging and monitoring services are foundational to a secure cloud architecture. This proactive and comprehensive security posture aligns with the principles of defense in depth and continuous security assurance, which are implicitly expected within the scope of the 1Z0-1072-20 certification. Adhering to these OCI best practices ensures that the infrastructure is not only functional, but also resilient against threats and compliant with general cloud security expectations. An incorrect approach that bypasses security configurations for speed would be professionally unacceptable. For instance, deploying resources without proper network segmentation, e.g., using public subnets for all resources without NSGs, creates an unnecessarily large attack surface, violating the principle of minimizing exposure. Similarly, granting overly broad IAM permissions to users or services, such as allowing administrative access to all OCI resources, directly contravenes the principle of least privilege, increasing the risk of unauthorized actions or accidental misconfigurations. Failing to enable logging and monitoring means that security incidents, if they occur, would go undetected, hindering incident response and post-mortem analysis, which is a critical failure in operational security. These actions demonstrate a disregard for established security best practices and a potential for regulatory noncompliance if specific data protection or operational security mandates were in place, even if not explicitly stated in the question's limited scope. The professional decision-making process for similar situations should involve a risk-based assessment. While speed is often a business driver, it should not override fundamental security and compliance requirements. Architects must advocate for incorporating security and compliance checks into the deployment pipeline from the outset. This involves understanding the OCI services available for security and governance, and integrating them into the design and implementation phases. When faced with pressure to compromise, professionals should clearly articulate the risks associated with shortcuts and propose alternative solutions that balance speed with security, such as phased rollouts or automated security checks within the CI/CD pipeline. Question 17. The review process indicates that a new OCI tenancy is being provisioned to host sensitive customer data, and the architecture team is proposing several approaches to secure this environment. Which approach best aligns with OCI's security best practices and a defense-in-depth strategy for protecting sensitive data? Option A. Focus on implementing security measures only after a security incident has been detected to minimize initial deployment complexity. Option B. Delegate all security configuration responsibilities to individual application development teams without a centralized security review process. Option C. Implement granular identity and access management (EAM) policies. Configure network security groups (NSG) and security lists for network traffic control, and enable Oracle Key Management Service (KMS) for data encryption at rest and in transit. Option D. Rely primarily on firewall rules at the edge of the OCI network to block unauthorized external access, assuming internal systems are inherently secure. The correct answer is C. Implement granular identity and access management (EAM) policies. Configure network security groups (NSG) and security lists for network traffic control, and enable Oracle Key Management Service (KMS) for data encryption at rest and in transit. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, where the need for rapid deployment and feature iteration clashes with the imperative to maintain robust security and compliance. The core tension lies in balancing agility with the responsibility to protect sensitive data and adhere to regulatory mandates. Architects must make informed decisions that prioritize security without unduly hindering business objectives, a delicate act requiring deep understanding of both OCI services and relevant compliance frameworks. The challenge is amplified by the dynamic nature of cloud environments, where new services and configurations are constantly introduced, demanding continuous vigilance. Correct approach analysis. The correct approach emphasizes a proactive, layered security strategy integrated from the inception of the architecture. This involves leveraging OCI's native security services, such as Identity and Access Management (EAM), for granular control over resource access, network security groups (NSG) and security lists for network traffic filtering, and Oracle Key Management Service (KMS) for data encryption. Furthermore, implementing robust logging and monitoring through OCI's audit service and integrating with security information and event management (SIEM) tools allows for continuous threat detection and incident response. This approach aligns with best practices for cloud security and compliance, ensuring that security is not an afterthought but a fundamental component of the cloud infrastructure. It demonstrates a commitment to data protection and operational integrity, which are paramount in any regulated industry. Incorrect approaches analysis. One incorrect approach involves relying solely on perimeter security without considering internal threats or misconfigurations. This is a failure to adopt a defense-in-depth strategy, leaving the environment vulnerable to insider threats or compromised credentials. It also neglects the shared responsibility model in cloud computing, where the customer is responsible for securing data and applications within the cloud. Another incorrect approach is to defer security configuration to the application development teams without providing clear guidelines or oversight. This can lead to inconsistent security implementations, overlooked vulnerabilities, and a lack of centralized security posture management. It fails to establish a unified security framework and can result in a fragmented and insecure environment. A third incorrect approach is to implement security controls reactively, only addressing issues after a security incident has occurred. This approach is fundamentally flawed as it prioritizes damage control over prevention. It demonstrates a lack of foresight and a failure to adhere to proactive security principles, which are essential for maintaining a secure and compliant cloud environment. This reactive stance can lead to significant reputational damage and regulatory penalties. Professional reasoning. Professionals should adopt a risk-based approach, continuously assessing potential threats and vulnerabilities. This involves understanding the specific compliance requirements applicable to the data being handled and the industry sector. The decision-making process should prioritize implementing controls that mitigate the highest risks first, while ensuring that these controls are integrated seamlessly into the OCI architecture. Regular security audits, penetration testing, and adherence to OCI's security best practices are crucial. Furthermore, fostering a culture of security awareness among all stakeholders, including development and operations teams, is vital for maintaining a secure cloud posture. Question 18. The analysis reveals that a cloud architect is designing an application on Oracle Cloud Infrastructure, OCI, that requires managing sensitive credentials, such as API keys and database passwords, across multiple development and operational teams. The architect needs to ensure these credentials are secure, auditable, and easily rotated without compromising application functionality or violating data protection regulations. Which approach best satisfies these requirements while adhering to OCI best practices for secret management? Option A. Utilize OCI Vault to securely store and manage all sensitive credentials, granting access to applications and teams through fine-grained policies. Option B. Embed credentials as plain text within compute instance metadata or user data scripts. Option C. Store credentials directly within application configuration files that are checked into a version control system. Option D. Place encrypted credential files in OCI object storage, with access controlled by bucket policies. Correct answer is A. Utilize OCI Vault to securely store and manage all sensitive credentials, granting access to applications and teams through fine-grained policies. Explanation. Scenario analysis. This scenario presents a common challenge in cloud architecture, balancing the need for rapid development and deployment with robust security and compliance requirements. The architect must ensure that the chosen OCI services and their configurations adhere to best practices for data protection and access control, which are critical for maintaining customer trust and meeting regulatory obligations. The challenge lies in identifying the most effective and compliant method for managing sensitive data within OCI, especially when dealing with multiple teams and varying access needs. Correct approach analysis. The correct approach leverages OCI Vault for secure storage and management of secrets, such as API keys and database credentials. This aligns with the principle of least privilege and centralized secret management, a cornerstone of cloud security best practices. OCI Vault provides robust encryption, access control policies, and auditing capabilities, ensuring that sensitive information is protected from unauthorized access and that its usage is traceable. This directly supports compliance with data protection regulations by minimizing the exposure of sensitive credentials and providing a secure mechanism for their distribution to authorized applications and personnel. Incorrect approaches analysis. Storing secrets directly within application code or configuration files is a significant security and compliance failure. This practice exposes credentials to version control systems and potentially to unauthorized individuals who gain access to the codebase, violating principles of secure development and data protection. It also makes credential rotation extremely difficult and error-prone, increasing the risk of compromised credentials. Using object storage, e.g., OCI object storage, to store secrets in plain text or encrypted files without proper access controls is also a failure. While object storage can be used for data archiving, it is not designed for the secure, granular management of secrets. Without robust access policies and encryption key management, secrets stored in object storage are vulnerable to unauthorized retrieval, leading to potential data breaches and noncompliance with data privacy regulations. Hard-coding secrets into compute instance metadata or user data scripts is another critical failure. This method makes secrets visible to anyone with access to the instance's metadata or boot scripts, creating a severe security vulnerability. It also negates the benefits of centralized secret management and makes auditing and rotation of secrets nearly impossible, directly contravening best practices for secure cloud operations and regulatory requirements for data security. Professional reasoning. Professionals should approach this challenge by first understanding the sensitivity of the data and the regulatory landscape applicable to their organization. A thorough risk assessment should guide the selection of services and configurations. The decision-making process should prioritize solutions that offer centralized management, strong encryption, granular access control, and comprehensive auditing. When in doubt, consulting OCI documentation on security best practices and relevant compliance frameworks is essential. The principle of least privilege should be applied rigorously to all access controls. Question 19. Cost-benefit analysis shows that migrating an on-premises monolithic application to Oracle Cloud Infrastructure, OCI, presents several architectural options, each with varying timelines and potential long-term operational costs. The business requires a rapid deployment to meet an upcoming market opportunity. Which architectural approach best balances immediate business needs with long-term OCI best practices and cost optimization? Option A. Implement a lift-and-shift migration to OCI compute instances, followed by a phased refactoring and modernization strategy to leverage OCI managed services and optimize costs over time. Option B. Migrate the application as is to OCI virtual machines and defer any architectural changes or optimizations until after the initial market opportunity has passed. Option C. Undertake a complete re-architecture of the monolithic application into microservices using OCI Container Engine for Kubernetes OAK and serverless functions before any migration begins. Option D. Replicate the on-premises infrastructure directly onto OCI using a combination of OCI compute and block storage, without any modifications to the application code or architecture. Correct answer is A. Implement a lift-and-shift migration to OCI compute instances, followed by a phased refactoring and modernization strategy to leverage OCI managed services and optimize costs over time. Explanation. This scenario presents a common challenge in cloud architecture, balancing the immediate need for rapid deployment with the long-term implications of architectural choices on operational efficiency and cost. The challenge lies in the inherent tension between agility and governance. A technically sound solution that prioritizes speed might inadvertently create technical debt or incur significant, unforeseen operational costs, impacting the business's bottom line and potentially violating principles of responsible resource management. The correct approach represents best professional practice because it integrates a comprehensive evaluation of both technical feasibility and business impact. It acknowledges that a lift and shift might be the fastest path to migration, but fails to leverage cloud-native capabilities for optimization. By proposing a phased approach that includes refactoring and modernization, it demonstrates a commitment to long-term sustainability, cost-effectiveness, and adherence to cloud best practices for performance and scalability. This aligns with the professional responsibility to deliver solutions that are not only functional, but also economically viable and operationally sound, ensuring the business receives maximum value from its cloud investment. An incorrect approach that solely focuses on the quickest migration path without considering future optimization or cost implications fails to uphold professional diligence. It risks creating a brittle, expensive-to-maintain system that will require significant rework later, potentially leading to budget overruns and project delays. This demonstrates a lack of foresight and a failure to consider the total cost of ownership, which is a critical aspect of responsible cloud architecture. Another incorrect approach that prioritizes a complete re-architecture from the outset, without a clear understanding of the business's immediate needs or the complexity involved, can lead to project paralysis and missed business opportunities. While modernization is valuable, an overly ambitious initial scope can be counterproductive if it delays the core migration objective. This approach might be driven by a desire for technical perfection rather than a pragmatic assessment of business priorities and resource constraints. The professional decision-making process for similar situations should involve a structured evaluation framework. This includes understanding the core business drivers and constraints, assessing the technical landscape and potential cloud-native solutions, performing a thorough cost-benefit analysis that considers both upfront migration costs and ongoing operational expenses, including potential savings from optimization, evaluating risks associated with different migration strategies, and developing a phased roadmap that balances speed to market with long-term architectural integrity and cost efficiency. This iterative and holistic approach ensures that architectural decisions are aligned with business objectives and adhere to principles of sound engineering and financial stewardship. Question 20. The investigation demonstrates that a financial services firm operating under U.S. federal regulations has deployed a critical customer data processing application on Oracle Cloud infrastructure without explicitly configuring the service to adhere to specific data residency mandates for sensitive financial information. What is the most appropriate architectural approach to ensure compliance with U.S. data residency regulations for this application? Option A. Address data residency concerns by implementing data masking techniques after the data has been processed, rather than controlling its physical location. Option B. Architect the solution to deploy all OCI services and store all customer data within OCI US regions, specifically selecting regions that align with the firm's regulatory obligations for data processing and storage. Option C. Assume that Oracle Cloud Infrastructure's global network automatically ensures compliance with U.S. data residency regulations for all deployed services. Option D. Rely on the default security and compliance settings provided by OCI for all services, without further configuration, to meet U.S. data residency requirements. Correct answer is B. Architect the solution to deploy all OCI services and store all customer data within OCI US regions, specifically selecting regions that align with the firm's regulatory obligations for data processing and storage. Explanation. Scenario analysis. This scenario presents a professional challenge stemming from the inherent tension between rapid cloud adoption and the imperative of maintaining regulatory compliance. Organizations often prioritize agility and innovation, which can inadvertently lead to the deployment of services without a thorough understanding of their data residency and sovereignty implications. The challenge lies in balancing business needs with the legal and ethical obligations to protect sensitive data according to specific jurisdictional requirements. This requires a proactive and informed approach to cloud architecture, rather than a reactive one. Correct approach analysis. The correct approach involves a comprehensive assessment of data residency and sovereignty requirements before deploying services. This means understanding the specific regulations applicable to the data being processed and stored within Oracle Cloud Infrastructure, OCI. For the 1Z0-1072-20 exam, the implicit jurisdiction is U.S.-based, as Oracle is a U.S. company, and its primary regulatory environment for cloud services often aligns with U.S. federal and state laws. Best professional practice dictates leveraging OCI's region and availability domain structure to ensure data is stored and processed within approved geographical boundaries. This includes utilizing OCI services that offer granular control over data location and adhering to OCI's shared responsibility model for security and compliance. Architecting solutions to meet these requirements proactively demonstrates due diligence and mitigates the risk of regulatory penalties and reputational damage. Incorrect approaches analysis. One incorrect approach involves assuming that OCI's global infrastructure automatically satisfies all data residency requirements. This is a failure to acknowledge the shared responsibility model and the specific legal obligations of the organization. Regulatory frameworks, particularly in sensitive sectors like finance or healthcare, often mandate that data remain within specific national borders or be subject to specific legal jurisdictions, regardless of the cloud provider's global presence. Another incorrect approach is to rely solely on the cloud provider's default configurations without verifying their alignment with specific regulatory mandates. While OCI provides robust security and compliance features, these must be actively configured and validated by the customer to meet their unique regulatory obligations. A failure to do so can lead to non-compliance, as default settings may not be sufficient for all use cases or jurisdictions. A third incorrect approach is to address data residency concerns only after a regulatory audit or incident. This reactive stance is professionally unacceptable, as it indicates a lack of foresight and a failure to implement preventative controls. It exposes the organization to significant legal and financial risks, including fines, sanctions, and loss of customer trust. Professional reasoning. Professionals should adopt a risk-based approach to cloud architecture, prioritizing compliance from the initial design phase. This involves 1. Identifying all applicable regulatory frameworks and data sovereignty requirements relevant to the data being handled. 2. Understanding the capabilities of OCI services to meet these requirements, particularly regarding data location and access controls. 3. Designing solutions that explicitly incorporate these compliance controls, leveraging OCI's regional deployment options and security features. 4. Regularly reviewing and updating architectures to adapt to evolving regulations and OCI service offerings. 5. Documenting all compliance-related decisions and configurations for auditability.